This is May 2012, Paper 1, Time Zone 1, question number 1. And it is a question about a series. The series is represented in sigma notation. It's the sum of k times a third to the r. And r is going to count, starting at 1 up to infinity. Now, you should recognize that this is a geometric series, but just to make that super clear, let's have a look at what happens when r is 1, when r is 2, when r is 3, and when r is 4. And you can skip ahead if you're reasonably happy with this. So when r is 1, this blue expression here becomes... So I'm not actually evaluating that expression, I'm just evaluating the first term in that series. So when r is 1, this term means k times a third to the power of 1. When r is 2, same expression, means k times a third squared. When r is 3, it's k times a third cubed, and when r is 4, k times a third to the 4, and so on. And what the sigma means is that we're adding up each of these things. And now it should be even easier to recognize that it's a geometric series, because each term in this series is just the previous one multiplied by 1/3. Now, I don't necessarily think you need to write any of that down in order to answer the question. What is a good idea to write down is that the first term of this sequence, well, we've already identified the first term, is a third of k. And that the ratio in this sequence, well, again, we've already identified the ratio each time, is a third. And it's a bit hard to see now that I've sort of obscured it with all this highlighting, but the sum that we're evaluating is the sum to infinity. So this sequence is going on forever. And that's okay, because r is less than 1 and bigger than minus 1. So we can evaluate it. R is only a third. So we can evaluate the sum to infinity using the formula that is in the formula booklet. The sum to infinity, which they usually just call s, sometimes s with a little infinity symbol, is u1 over 1 minus r. Okay, so let's put in what we know. u1, well, that's k over 3 over 1 minus r is equal to, and we get told the sum to infinity is 7. So now it's just a case of solving this equation and finding the value of k. So we've got k over 3 over 2 over 3 is equal to 7. And what I like to do when I've got fractions in fractions is look for a way to multiply the top and the bottom by the same thing in order to get rid of the fractions inside the bigger fraction. So my big fraction contains two things that have both got thirds in. If I multiply the top by 3, I'm just going to get k. If I multiply the bottom by 3, I get 2, and I end up with a fraction. K over 2 is 7. And from there it's easy to see that therefore k is 14.